Yes, hello. This is Angela Gentry, the new and improved wrinkle-free version, as long as I don't have HD. So I'm going to try to get you warmed back up. And I know the light shining in, I can't help it. I'm in a spot where I'm fairly comfortable to do the recording. So hopefully that doesn't bother you. But anyway, so I'm going to go back over factoring because we need it for the exam and you definitely need it for the next class. And then just to get us warmed back up, and I'll do my best for you, and hopefully as you have questions, you will email me or whoever may be your instructor this semester and just ask them questions. So it says factor completely. So this is the factoring summary, where if I were in class with you, I would always yell GCF, GCF, because if it doesn't matter what you're factoring, you should always pull the GCF first, because it helps break down and then factor completely at the end and not miss out on factoring a piece. So this is a 4-term polynomial. So what do? So it says determine, so first check for a GCF. There isn't one between all those 4 terms. Then you say, well, how many terms do I have? Well, if it's 4 terms, you factor by grouping. So in class, I would say, hey, we call this double bubble. You can group it however you want. I call it double bubble. It tends to help students. And oops, hang on. Oh, okay. Sorry, I'm still relearning these tools. So I have to get faster. So you do want this sign in the second bubble. I'm going to make my pen just a little smaller. You'll have to bear with me on this first one. After this, it'll be better. And then what you do, from each group, you pull the GCF. So in this case, what do you have in common between 12x squared and 30x? They both have a 6x. And then you pull that forward and you open a parentheses and say 6x times what is 12x squared? 2x. And 6x times what is negative 30x? Negative 5. Close. Then you bring down this sign. Please bring a sign down. Lots of folks don't, and then they actually have all multiplication, which is not correct. It's not the original. So then you say, what do these 2 terms have in common? A 5, and then you open, and 5 times what is 10x? 2x. And 5 times what is negative 25? Negative 5. And then, so originally, if you look at this, you had 4 terms, 1, 2, 3, 4. And now you have, actually how many terms? You have 2 bigger terms. This is a term, and then this other piece is a term. And then you notice these 2 terms have this piece in common. It's common binomial factor, and you pull that forward. And then you put what we call in class the leftovers, meaning this guy and this one, into the second set. And do you see how now you have one big ugly term, but it's one big term. There is nothing, there's no plus or minus separating these pieces. This is multiplication, meaning it's completely factored. So if I misspeak or make a mistake, it's because I'm on the spot here and I have to make this a fairly decent recording because it's going to go to a lot of people. So I'm doing my best. It's also morning, so let's look at this one. I say factor, you say greatest common factor, is there one? No, and then you say, what is it? Oh, it's one of these. Meaning it's a trinomial, but the leading coefficient is technically 1, meaning there's just 1x squared. So in those, we've learned that we should just open, close, and XX. And we shouldn't, you shouldn't do this one by grouping. And then you say, well, this piece here is that product. So when you multiply this one times this one, it has to become the C, which is why we then do this piece In my class, I put the product up here, I put the sum down here, and then I play with this around until I find the two numbers that make that happen. So let's look at this one here, the actual example. I'm going to open, close, Z, Z. German Z's are a little different than what you're used to. It's okay. The product is -3. I always pull my sign over here so I don't have to fiddle with, hey, is this over here plus or minus, which one's what? So the product is -3. The sum is that piece in the middle. Like when you're combining the like terms, you get that piece in the middle. So the sum in this case is the coefficient of the middle term, which is a 2. And then you play with this and find two numbers that when you multiply them, you get a -3. And when you add them, you get a 2. So if you look at a 3 and a -1, 3 times -1 is -3, and 3 minus 1 is a +2, which is exactly what you need. So then you simply put these pieces in here. There's no need to group, folks. I know a lot of folks they start liking that grouping method, which I love the grouping method, but not for these type of problems because this is simply open, close, and this makes it quicker. So you simply put these two pieces into that, and now it's completely factored, and then you can check it back by FOIL. We could have done that with the previous one too. So Z times Z, Z squared minus 1Z plus 3Z, that's 2Z. True. 3 times -1, -3. Okay, now I'm not going to make the recording over all of factoring summary, I don't believe, but we'll see. I'm going to keep track of how much time I'm spending on here, roughly. Whoops. But I'd really like to get through quite a bit. For this one here, number 3, and I might need to put a space in here. Bear with me here. I'm working with a pen and at the same time with my regular computer. Okay. So I say factor, you say greatest common factor always. So this is still, you use those steps that I listed at the top. You know, if you need to take notes throughout, you can always rewind the video and take notes, but you always want to keep track of these steps. So is there GCF? You check it. And in this case, no. And then you ask how many terms. This is a trinomial. And then you say, well, is it a simple trinomial that just starts with x squared, where you simply open, close, and no. And this is after you already pulled the GCF, which there isn't one. And then you say, okay, now I'm going to use the grouping method if you choose to do that. Now, some of you can do trial and error or guess and check methods. I'm fine with that. But I teach the grouping method because it works for all my students, okay? So I'm not sure which way you learned from previous instructors. Be open to this because it'll help you. But if you choose to do it, guess and check, please don't. That's okay, you know? But my folks would have learned that, hey, I'm going to go over the top. And what that means is that that product that they find is now the A times the C. And this is how it'll be explained in the book. But 15 times 8 is 120. And then your sum is 22. And then you find two values that make that happen. And it's a 10 and a 12. And then you would say, okay, I'm not going to go ahead and put that in there because look, students do this all the time, but this wouldn't check. X times X is not 15X squared. And then you get a 12X plus a 10X is 22X, but you wouldn't get the 15X squared. So this isn't going to work. So you need to, I'm going to say, let's split the middle term into 2. You're going to use these pieces to do that. And then you leave the first term and the last term. But you split the middle into 2. And I'm going to put the 10 near the 15. But you see how now you can combine, if you combine them, you'd get right back to where you were and you didn't change your original problem. And you see now you're just going to factor by grouping. So now you're going to do the double bubble thing. And I'm not going to finish this one. because I just showed one with factoring by grouping, okay? And I'm trying to make this efficient for you because we're all limited on internet space. Okay. Sometimes I do want to show one. Oh, there might be one. Hang on a minute. Here's another trinomial that I wanted to look at first. Excuse me. So I say factor, you say greatest common factor. Is there one? So this is a 7, 7, and this is 2 times 2s and 3s, so 36 if you broke it down. So these three terms together have nothing in common. Then I would normally say, oh, my leading coefficient is not 1, so I'm going to go over the top. Now look at this. Don't write this down. But look at this. If I go over the top, I'm going to have a product, and I'm just going to call it hideous because I don't want to deal with it. Do you see how 49 times 36 is a big number? So if you get a big number, then you might want to consider, is it maybe special? And you're going to say, well, if it's special, then you're going to be able to use that formula. The formula, we have two formulas. This is a perfect square trinomial, possibly. I'm not saying it is, but I'm going to say possibly it's a perfect square trinomial. Whoops, I'm trying to erase. Okay, so if it's a perfect square trinomial, we could factor it. You were given these in the exams. You're given these formulas. So what this means is this is a perfect square trinomial, then it factors into a binomial squared, which makes it really quick. So what you look at is, hey, if a squared were 49x squared, what would a be? So you're going to ask what squared, excuse me, what squared is 49x squared? 7x. And then you're going to say, well, if b squared is that last piece, that would be convenient because then it's maybe a perfect square trinomial. So then you can say, well, what squared gives me 36? 6. And then the question is only special if this is 2ab. So I usually say take the a times the b, which is 42x, and you double it. Don't worry about signs. And if that is what this ends up coming out as, so 42x times 2 is 84x, wonderful, it is a perfect square trinomial. So you simply do the binomial, you use the a, you use the b, you use this sign, and you square it, and there you go, it's completely done. You can do this one over the top where you split the middle. You would end up finding that this is a 42 and a 42. The problem is, it's a negative because that's a negative 84, etc. But you wouldn't normally see this very easily. So I'm trying to help you out here. If it gets big, think, is it maybe special?